Regardless whether the engine uses a carburettor, throttle body injection, multi-point indirect injection or GDI technology, the purpose of the fuel system is to supply an ideal fuel mixture to the cylinders for combustion. Welcome to the Ryco Filters Training Academy. We can divide the fuel system of a modern vehicle into three distinct parts: air supply, fuel delivery and fuel metering. The fuel delivery system is designed to supply either a carburettor, fuel injectors or high pressure pump with a desired quantity of clean fuel at a specified pressure. For most EFI engines, the fuel stored in the tank is transferred to the fuel rail or high pressure system by an in-tank low pressure fuel pump. The fuel pump is generally housed in what is referred to as a modular reservoir assembly and is also home to the fuel sender unit, primary filter and in some models the fuel pressure regulator. Carburetted engines may use either an electric or mechanical low pressure fuel pump, in which case the fuel pressure available is only around 7 psi, while a modern GDI system requires around 60 psi of pressurised fuel to be available for the high pressure pump. The air or induction system provides a continuous supply of clean filtered air for combustion. A quality air filter is required to separate and trap dust particles that would otherwise flow to and abrade moving engine components. The airflow is measured and ducted through the intake, where volume control is achieved by opening and closing the throttle valve. Engine speed is primarily controlled in any petrol engine through the manipulation of the supplied intake air into the combustion chambers. The fuel metering system is probably the busiest part of an engine's operation. Depending on which system is fitted, will determine how complex the control will be. A carburettor is by far the simplest of all. Its mechanical construction only allows for mixture adaptations with changes in airspeed through the carburettor. Jets, air correctors, emulsion tubes and chokes all play a part in controlling mixtures to acceptable values for any given throttle position and engine load. Unfortunately, due to the fixed size of these components, not all operating conditions are met satisfactorily. Manufacturers tend to design their systems to overfuel the engine across all operating ranges as a band-aid solution. In reality, this is what brought about the end of the carburettor. Without infinite control over the fuel entering the engine, emission targets just couldn't be met. Multi-point injection is by far the most common of the injection systems used by automotive manufacturers. The fuel injector performs the same basic task as the carburettor. Pressurised fuel is supplied to each injector, whereby upon command from the engine control unit, the injectors are opened, allowing a small quantity of atomised fuel to enter the engine intake. The fuel mixes with the incoming airstream and is drawn into the combustion chamber on the intake stroke. The engine control unit is able to adjust how much fuel enters the cylinders by altering the amount of time each injector is opened. The ECU is able to calculate this value based on feedback from the airflow meter, throttle position and oxygen sensors. Gasoline direct injection is one of the newer technologies found in modern petrol vehicles. Unlike multi-point injection, the injectors spray fuel directly into the combustion chambers and do so at very high pressures. Fuel is drawn from the tank by the low pressure fuel pump and delivered to the high pressure side at close to 60 psi. This is roughly double that of a multi-point injected system. The high pressure pump then increases the fuel pressure to around 2500 psi, where it is delivered to the fuel injectors via a fuel rail assembly. This extremely high pressure allows complete atomisation of the fuel particles, enabling a more complete mixture to occur within the combustion chamber. GDI systems generally inject fuel on the compression stroke, which allows for more aggressive ignition timing and much leaner mixtures to be attained. These systems are very efficient and produce much lower exhaust emissions than their multi-point injected counterparts, although, due to the extremely close tolerances of the high pressure pump and injectors, exceptionally clean fuel is required. As with any of the fuel delivery, air supply and metering systems found on a modern petrol engine, it's imperative that we not just use the correct filter, but a high quality one at that. Keep following the Ryco Filters Training Academy and develop your knowledge with the market leaders in filtration. Thanks for watching.